In this video, we're going to be tackling this noise generator board. No, I mean tone board. Actually, I said that correctly. It is a noise generator board currently, and I'll explain why. You can see right there, they're using these C-1917s, and look at those leads on every single one of them. Every single one of those NPN transistors right there, and even the PNPs back here too as well, have that silver coating. Well, no longer silver no more. It's actually oxidized and corroded. And they used to do that back in the day with these transistors because they figured it would conduct better. So they put a silver coating on those leads, and over time, they of course corrode and oxidize. It works its way into the package. And typically, usually the first time they're going bad is when you tap on the front panel of the receiver and you get a lot of static popping and crackling. It's typically due to these going bad. And that's because they come leaky over time. And if not leaky, they actually go lower in gain. Sometimes they even open up and just go bad altogether and stuff like that. So anytime you see these in the audio signal path and stuff like that, just replace them right off the bat. Same thing with these PMP right there. And thankfully, because it's a common problem I deal with a lot, I'm actually going to substitute them with, let's just see right there, you can see there 1845s, which is typically what I use to substitute those NPNs. And as far as the PMP transistors, I also got these laying around. Even though these aren't the ideal one I would like to use, they will work. They're JC2907s, so we'll use those for the PMP to substitute those. So for those that want to do it, there, I told you what you can substitute it with. We're also going to go and change all the capacitors on this board while we have it out, because it wasn't easy getting that board up, but of course I had to redo all the switches and stuff, so I figure while I have everything apart and have it out, I might as well go ahead and tackle this noise generator board while I'm at it, and hopefully turn it effectively into a tone board instead. And then we'll go ahead and tackle this mess right here. And you can see this definitely was repaired before. So we'll go and clean that up. We'll put LEDs in it, of course. And then we'll go ahead and hopefully I'll get the emitters. The emitters are not easy to find for these. And the reason for it is because if you go on DigiKey or any of the parts supplier, they're pretty much backdoored for a year. So you have to go through obviously other sources to get it, and then it takes a couple weeks to get it. So that's why I'm holding off on the amplifier, because I also had to get the diodes as well and stuff like that, and to redo the rest of the PMP and NPN transistors on this board, because even though I did test the diodes and they all tested good out of circuit, the problem is that's not a good way to actually test diode and transistors, because they typically break down when they're under load and stuff, not like that, not out of circuit. So yeah, you can put them on your component tester and they'll test fine actually, but it's when you put them under load and stuff like that, that's when they tend to fail. Or of course you can put it on a curve tracer and stuff like that, and you'll kind of see where they break down and stuff. But either way it goes, if you see them, it's just better just to replace them, and it saves you tons of hours of having to troubleshoot, check voltages and stuff like that to see where the failure is, when you know it's a high failure weight as it is on these receivers. So I always just end up changing them all out when I do a full restoration. That ensures that it's going to be reliable for years, versus where I go and replace the one bad one and then the others start to fail. So better to be safe than sorry, as I say, you know what I mean? But either way it goes, once I get the rest of the components, and some of them I have to wait because they were either on back order or I had to order them through other suppliers and stuff like that. So it's not easy getting some of the parts, especially those emitter resistors, which actually were quite more pricier than they should be, because I had to go to a third-party seller instead of a parts supplier. But we'll go ahead and tackle this board, and I'll be right back once I get all the components off, put the new components in there. And we're actually going to put those on a component tester just to see what the HFE tested and stuff. So here you go, I got one of the transistors on a component tester. We'll just see what the HEF says on this one here. And I kind of test them already, and you can see it's actually not testing as bad as I would expect them to be. And they all tested around that range essentially and stuff like that. So These haven't necessarily failed yet, but like I said, this is not a good way, a proper way of testing them actually and stuff. Usually though, when they start to go bad, I'll see the HEF drop to like 60, 50s and stuff like that. And that typically is a good sign that, yeah, they're definitely failing, going bad. But this case here, it's not showing it, but either way it goes, we're still going to substitute them. Because when the leads get that bad and stuff like that, typically, like I said, they don't necessarily just fail, but by tapping them or any type of movement and stuff, they'll start making static, crackle, and pop and stuff. So that's why you want to change them, regardless, even if they test okay. So one thing that I want to let people know is when you're looking to replace transistors and stuff, make sure you got base, emitter, and collector right. So like we go to this old one right here and retest it, we can see pin 1 red is going to be this one right here, and that's going to be emitter, 2 is going to be collector, and then 3 is going to be base. And you want to match it, of course, to the new ones as well when you're installing them, because some of these older transistors will actually mess you up, and you'll go ahead and test them, and you know the pin arrangement will be completely different. It might be, instead of 1 being emitter, it could be 1 being base and stuff like that, and you can actually install them incorrectly and stuff. And usually I just do a note when I test them and stuff like that, and therefore I make sure I get them in the right orientation and so forth. Here's a good example of why you need to check the orientation of the pins on the transistor there, because you can see on these PNP 1 is B, 2 is collector, 3 is emitter. So if I go and take this out here, which I will now, sorry about the focus, you can see that black corrosion's even getting in the socket. Okay, I think I got that in. Alright, actually, let me help put the same. Okay. And you can see on the new one, it's going to be 1's emitter, 2 is base, and then 3 is collector. So make sure you install these right. One of the things you do definitely want to test when you see them, and right here in this heat sleeve right there, they have fusible resistors there. And you want to test those. As you can see there, the value there is green, blue, black, so that's 56 ohms. So you want to make sure it measures close to 56 ohms. Of course, I already zeroed out the meter for lead resistance and stuff. So now we'll go ahead and test it right there. And yeah, it's measuring pretty much bang on, so those are good. And I do got to test that one too as well. But either way it goes, you also see them on the amplifier there. And those should be between 4.8 to 5.2 ohms. So you do want to test those as well. And you also want to test these two as well. Those should be about 68 ohms. So, and these two actually tested bad. They were both open, so I have to change those, which I'm waiting for. But either way it goes, make sure you test the fusible resistors and stuff too while you're at it. So as you can see, now I effectively turned this noise generator board into a tone board. Yep, I went ahead and changed all the transistors, as you can see, because I had the unfortunately black corrosion of death, as I referred to it as. Went ahead and also recapped the board while I was at it. I went ahead and checked the 2 fusible flammable resistors right there to make sure they were within spec. And I also checked a few other resistors and stuff to make sure they didn't drift and so forth. I also went ahead and cleaned the pod with Deox fader lube and stuff. So this board's ready to be installed. So the next part, of course, will be getting this amplifier section sorted. Right now I'm still waiting on parts. Unfortunately, I'm going to have to wait a while till I get all the emitter resistors and every other component like the diodes and stuff that I need to complete this project. But I figure I'll go ahead and get the switches, the tone board, everything associated with the amplifier going. So when I go ahead and do testing and stuff like that, I'm going to get actually good results versus having to worry about secondary issues and stuff like that. So that's why I'm doing everything around it right now, including even the switches and stuff, because I don't want no secondary faults when I go ahead and set the bias and check offset and everything else on the amplifier. But here you go, and hopefully the next upcoming parts, at least one of them, will be of the amplifier stage actually working. So tuner board's wired back in, and for those that want to know where the wires go, of course, there you go. And I'll go ahead and bolt it back down. As you can see, the tone board's completely back in the chassis. And when you go ahead and run the wire, make sure you run it underneath the control rod that goes to the selector switch in the back, because you don't want this binding up with this. And you can see there, I routed the same way it was before. And yeah, we got it bolted down, so that part's done now. So this concludes part 3 video, and like I said, hopefully the next part I'll have more parts in.